We're going to begin today with some more teaching lectures rather than doing math concepts. And I want to talk today about goals for primary math. Goals for primary math. You're learning primary math teaching. You're having to teach in our first grade and in our second grade. So now let's think about, what are you trying to do as a primary teacher? What is important as a primary teacher, and so forth. So goals for primary math. First goal. As you know, I kind of put third grade on the border. So primary math is pretty much, we're dealing with first and second grade. Okay, so primary math is primarily first and second grade. So our first goal is to lay a solid foundation by the time third grade is done. By the time third grade is done, your third graders should have basic math skills. The following basic math skills. First of all, they need to understand number concepts. So by the time we're done with third grade, our foundation has to be completely poured and set. Okay, we're laying foundations. That's our first goal, to lay a solid foundation by the time third grade is done. First of all, in understanding number concepts. This goes all the way back to kindergarten even. Number recognition, number writing, counting, of course, is all involved in the very first stages of doing mathematics in kindergarten. But then by the end of third grade, we have to have, most important of all, an understanding of place value. Okay, so yes, we have all of our number recognition, number writing, number counting of our kindergarten years, but we also have to master and understand place value. We have to be able to write and read our larger numbers and understand that place value is 10 times bigger, 10 times bigger. If we don't understand place value, we're going to have trouble with our numbers later on. We're going to have real trouble with the decimal point in fifth grade if we don't understand the decimal place. We're not going to understand decimal place value if we don't really have a handle on regular place value, because decimal place value is an extension of what's in front of the decimal. Okay, and decimal place value, when we get to decimal place value in grade 5, it really shows when the students don't understand it. It really shows up in fifth grade when we have to expand place value behind the decimal. So basic number concepts, yes. We want to number recognition, number writing, counting, and all those things, because they are preparatory for learning basic skills. But the most important number concept for them to understand at the end of third grade is place value. The second thing that they need to understand at the end of third grade as far as number concepts is number order. Number order begins with before and after numbers. Number order then finishes with understanding and using the greater than and less than symbols. Okay, so we are laying a solid foundation by the time third grade is over. And the first area is number concepts. We do have to have all the foundational things that we learn in kindergarten and first grade. The number recognition, the number writing, the counting, etc. But number one is place value. But it also includes before and after numbers. And then that ends in being able to use the greater than and less than symbol. A third thing that needs to be mastered is also rounding. So I guess that's the fourth thing. The first thing being our basic number recognition, writing, and counting from kindergarten. Then place value is paramount. Then number order, which begins with before and after, and then ends with being able to use greater than and less than. And then the fourth concept is rounding. Rounding is the foundation of being able to understand estimation. All right, so number concepts. The second area that we're laying our foundation in is basic arithmetic skills with whole numbers. Basic arithmetic skills with whole numbers. Because guess what we're going to do at the end of 3rd grade and 4th grade? We're going to expand that into fraction math. Then we have to expand that in 5th and 6th grade into decimal math. So we have to have a solid foundation in basic arithmetic skills with whole numbers. Okay, underneath this means that they understand both the procedure and the associated concept. So we're talking about basic arithmetic skills with whole numbers. Underneath that includes the procedures and the associated concepts. Second idea, there are 4 basic operations that need to be understood. Okay, the 4 basic operations, they need to be understood. They also need to be practiced. And that, of course, would be addition, subtraction, multiplication, and division. So our second goal is to provide a solid foundation in basic arithmetic skills involving whole numbers. That means both procedure and concept, and it includes 4 basic operations: addition, subtraction, multiplication, and division. Next to addition, what do we need to stress procedure-wise? Think about it. We're teaching basic addition with whole numbers. What is the main procedure that must be mastered so they do it without thinking? What is that? When you're adding whole numbers, what's the main part of the procedure you have to teach? Come on, guys, wake up. Starts with a C. It involves place value. Well, let's bump down to subtraction. I'm going to get it out of you. You ready? With subtraction, what is the main procedure that must be mastered starting with a B? Borrowing. So back up to addition. What is the main addition procedure that must be mastered with addition? Carrying. There it is. Came out. Okay, so we want to provide a solid foundation in basic arithmetic skills. Of course, we're dealing with whole numbers, because we are going to expand to fractions and decimals. So we have to master addition, especially the procedure involving carrying. All right, and we have to understand addition concept. Who remembers the law of addition? Only add what? Like quantities, correct. So we're talking about giving them a solid foundation in basic arithmetic. And those operations are addition, subtraction, multiplication, and division. And remember, we're talking about procedures and their associated concepts. With addition, what's the procedure? Carrying. And what are the concepts of addition that need to be understood? The idea of adding likes. Okay, also with addition, what facts should be mastered? Keep in mind, I constantly want you to be aware of the 7 steps of our teaching progression. What are the 7 steps? Terminology, facts, concept, procedure. And we're kind of stop a little bit there with primary, don't we? Expansion is going to be beyond primary. So what concept do we have to learn with addition? We have to learn the law of likes. What procedure do we concentrate on with addition? Carrying. Now, what math facts? They're called the addition families, right? And usually through 18. Why 18? Because we pair our addition families with our subtraction families, and we have to be able to subtract 18 minus 9. We don't need 19 minus 9 because that's just 9 minus 9. isn't it? So up to 18. Remember, the addition families are grouped by the sum. So the 1 family is all the math facts where 1 is the sum. There's only 2. 0 plus 1 and 1 plus 0. For example, the 6 family would be all of the combinations that add to 6. 0 plus 6, 1 plus 5, 2 plus 3, 3 plus 2, 4 plus 1, 4 plus 2, 5 plus 1, and then 6 plus 0. Okay, that's the 6 family. Subtraction is grouped by the minuend. So the 6 subtraction family is 6 minus 0, 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4, 6 minus 5, 6 minus 6. Okay, so that's why we learn through 18, so that we can do 18 minus 9 when we borrow. So we do learn the addition families through 18 simultaneously with the subtraction families. Okay, now subtraction. What is the procedure that we center in? We've already said borrowing. Okay, what is the concept of subtraction? There are 2 ideas that they have to understand, 2 associated concepts with subtraction, and that, of course, would be the idea of order. If you go back to addition terminology, you know add in sum. We don't care whether it's 5 plus 1 or 1 plus 5 in our 6 family, really, do we? We have the same sum. But in subtraction, order matters. We have, in subtraction terminology, what's the terminology? Minuend, subtrahend, difference. So when you're teaching basic subtraction in grade 1, you have to make sure that, yes, they're going to borrow, but that's going to be later. The concept is order. We have to learn the minuend and subtrahend, and we can only subtract in the given order. Addition, it doesn't matter if I say 5 plus 1 or 1 plus 5. In arithmetic, I can't do 6 minus 1 and 1 minus 6, can I? So the first thing with subtraction is the distinct order involved. Minuend minus subtrahend. Okay, order does not matter in addition. Does anybody remember the property? Starts with a C. The commutative property of addition tells us that the order of the add-ins does not affect the sum. So my principle with subtraction would simply be that subtraction is not commutative. The order is distinct. Minuend minus subtrahend. That's the first concept with subtraction. Okay? And then with subtraction, what's another concept? Think about borrowing. How do we borrow with whole numbers? And this goes back to place value. How do we borrow with whole numbers? Different from borrowing with subtraction. In subtraction, we borrowed 1. What do we borrow in whole number subtraction? What do we borrow? We borrow 10. Okay, think about it. Let's say we're doing this subtraction. 5 and 1/4 minus 3 and 3/4. What do we borrow? We borrow 1, don't we? And so we have 5/4. What do I borrow in whole number subtraction? I better make this a little bigger, huh? 25 minus 16. I am borrowing 10 and making that 15. And so then that makes this one of my team families, 15 minus 6. That's why the team subtraction families are critical, which is why we learn the subtraction facts through 18, so that when I borrow, the biggest thing I'd ever have to borrow from, or subtract from, the biggest thing I'd have to subtract from is 18 minus 9. This is why we learn the 18 family, so that we can do the borrowing efficiently with the 8. I would never have to borrow for 19. Would I? No. Okay, that's why the 18 is the family that you need to get up to. Okay, so borrowing, of course, is the main procedure, but the associated concepts of subtraction would be order and then borrowing 10. Because we will expand to borrowing 1. We'll change from borrowing 10 to borrowing 1. What would happen if I borrowed 1 here, 10 here? I can't borrow 10, do I? Okay, I am borrowing 4/4, which is 1. I can't borrow 10s. So I borrow 10s only in fraction or whole number subtraction. I borrow 1 in fraction subtraction, which they're not going to be doing. They're not going to do that till grade 4. We're nowhere near borrowing and subtraction of fractions. Okay, so goal. We have a goal of providing what? A solid foundation by the end of 3rd grade. Okay, you need to work at it. The goal should not be finishing the textbook. Or I'm doing everything the curriculum says, I'm okay. No, we want to make sure our students have a foundation. They have these things down pat by the end of 3rd grade, okay? So basic number concepts, basic arithmetic skills, that's both the procedures and the associated concepts, and then our 4 basic operations of arithmetic, addition, subtraction. To finish subtraction then, the math facts would be the 18 subtraction family. So that we can do all of the minuends, 18 minus 9, okay? Obviously, when we do 18 minus 10, that's not as important of a fact because we can just do the 8. Same thing with 18 minus 11, even though these will be in the flashcards. We want to learn the subtraction family through 18, and by that I'm talking about 18 is the minuend, not the difference. Okay, you understand the difference between how the addition families are set up and how the subtraction families are set up. So, main concept with addition, main procedure with addition is carrying. Main concepts, of course, with addition would be the law of likes. There is no order important. Addition is commutative, so we don't even worry about it. All right. I haven't really said this, but I'm implying here that we're doing math skills. We still have to understand what addition is, what subtraction is, kind of what you were doing on your manipulatives, okay? And what you did, Amanda, on your visual. Subtraction is takeaway. All right, then multiplication. Multiplication takes off in grade 3. Okay? So with multiplication, we're not going to really do a whole lot in grades 1 and 2. So multiplication, what foundation should you establish in by the end of grade 2, then towards working for the end of grade 3? For multiplication, the main procedure that will be coming out is partial products. We have to be able to multiply beyond our times tables. So that means we have to be able to multiply with 2-digit multipliers or 2-digit factors. And when we have more than 1 digit in the multiplier, we have to line up our partial products. So that is a main procedure in grade 3. Because by the time we get out of primary and we start getting into the middle, we're going to really be taking off on expansion and procedures. So what's one of our main goals, which of course is my next one, I'm getting ahead of myself, is understanding what these skills are. So we need to lay a solid foundation in basic number concepts, basic arithmetic skills, which involve those 4 operations. For multiplication, our main procedure is partial products. Concept, What concepts are associated with basic multiplication of whole numbers? Pardon me? Of the first,
Like when you're in...
okay, we do have to carry. That's a procedure. Yes, and that kind of, we have to carry as well. But that kind of is expanded off of addition. So I would, if she mentioned carrying, did everybody hear that? That is also a procedure. We could add that to procedures with partial products. Carrying is a procedure. Now, I haven't taught third grade ever. I'm not planning on it. But maybe someday it'd be fun to just stop teaching my regular classes in the academy and bounce around to different grades. But so I haven't really dealt with teaching carrying in multiplication, only in addition and borrowing and subtraction. But that would definitely be a procedure. Think about concepts. Yes?
It's just skip counting?
Okay. I don't know what skip counting is, but I think we're talking the same concept. The idea that multiplication is repeated addition. And it is based on counting. Yes. So the idea of multiplication is a shortcut in sense. Multiplication is repeated addition. It is the shortcut of addition. Rather than adding, 3 plus 3 plus 3 plus 3, we just do 3 times 4. Skip counting, I don't know what that is. I have to find out. You'll have to tell me. It doesn't involve your fingers, does it?
No, I just didn't know what to call it. Just kind of when you count by 2s,
Count, yes.
or 4s.
Count by 3s, count by 2s, yes. And that's because it's repeated. It is repeated addition. The other concept is that multiplication is commutative. As I was talking about partial products, I mentioned the term multiplier. The top number used to be called, I guess still is called, the multiplicand, the bottom number, the multiplier. Those terms are not necessary. Do we need to distinguish which number's which in a multiplication problem? No, because multiplication is commutative. The order of the factors does not affect the sum. So we don't have to distinguish a multiplicand or a multiplier. It's not like subtraction where we have to distinguish the minuend from the subtrahend. So what we're going to do then is teach that multiplication is commutative. And multiplication is the shortcut of addition. But primarily what we have to do, the third thing, is we must master the multiplication tables through 12 at the end of third grade. Second grade starts, like Brooke said, with the counting. Counting by 2s and then multiplying by 2. Counting by 5s and then multiplying by 5s. Then we go back and pick up the 3s. Counting by 3s, multiplying by 3. And then we get up to about 5. Of course, we do 10s too. It's kind of hard to start memorizing the times 4, but that should be done around the end of grade 2. But by the time, and this is what we're talking about, laying a solid foundation by the end of grade 3. So the main thing with multiplication, by the end of grade 3, yes, we're going to have to teach them to carry when they're doing multiplication. We have to teach them to do their partial products, line up their partial products and add them. We do teach those procedures, but a lot of that will be re-emphasized again in 4th grade. The important thing for the primary teacher to teach about multiplication is the concepts and the facts. So the last thing with multiplication is we must memorize the multiplication tables through 12. Why? We're going to be expanding them. So our first goal is to lay a solid foundation in arithmetic by the time 3rd grade is done. First in number concepts, then in basic arithmetic skills with whole numbers. Addition, subtraction, multiplication, and division are our 4 basic skills. What about division? Where's the place of division in primary math? Procedure-wise, what we learn in primary math is how to set up a division problem. we learn to use this, the long division symbol. And we only do simple division with a single digit divisor. Okay? Then we'll do stuff that stays with the times tables. And they all come out even. Then eventually we do proceed to remainder. But with division, the main procedures that we're going to learn is the division symbol and how to set up a long division problem, though it's not very long for them. We also learn about remainders. But we don't really do much division. It's completely tethered to multiplication, which brings us to the second concept that we're dealing with division, and that is the fact that division is the opposite, which is a bad word for multiplication, because in algebra, opposite is subtraction. The word is reciprocal, but we don't use reciprocal in second grade. Instead, we should use the word inverse. So off the top of my head, I'm thinking it's the opposite operation to multiplication. But I got to fight that word, and I got to use the word inverse. But with third graders, second graders, they don't know the word inverse. So I do end up using the word opposite. But for you, the word is inverse. Division is the inverse operation of multiplication. And in fact, I said in first and second grade, we kind of learned the addition and subtraction together. All right? But once they get to multiplication and division, we have to really start understanding that division is the opposite operation of multiplication. I didn't mention the fact that subtraction and addition are inverse a minute ago. Why not? Primary students don't need to really get that yet, do they? So why is it more important for primary students and then elementary students to understand first that multiplication and division are inverse operations? Because that's how you divide. When you start doing a long division problem, what do you ask yourself? 3 times what equals 12? So for the primary student, it's much more important for them to understand that multiplication and division go together as inverses than it is for them to understand addition and subtraction as inverses. Does that make sense to you? So yes, addition and subtraction are inverse to each other. That does not really play that much of a role until you start solving equations, okay? Which they do in third grade. But the idea that multiplication and division are inverse is foundational to learning how to do division. A long division problem, even though I don't think that qualifies as a long division problem, but we start there. We start teaching division procedure, okay? So that's what I meant by setting up a long division problem. We start teaching them to, even with this simple problem, to put the 4 over the 2. And we teach them to multiply, subtract, okay? So we teach them how to set up very simple long division problems. While I'm at it, should you allow your second grader to put their 4 wherever they want it? No, you've got to, from the very beginning, teach them quotient placement. Do you see how primary teachers can cause problems down the road because they're not careful with little tiny details like quotient placement? Yeah, I know that doesn't matter, but it does matter. Okay, so little side note there. Okay, so when we're doing our basic skills, we want them to, with division, we are going to procedure-wise basically be teaching them how to set up a long division problem. Procedure-wise, we do teach them that division is the inverse operation of multiplication so that we can do a long division problem. Division facts. I have a confession to make. I never drilled division facts because they are so closely associated with the multiplication. I don't mean in second grade. I did do it in second grade, but I never did it in 5th and 6th grade. I don't think I did it much in 4th grade. I taught 4th grade a couple of years. Taught 5th grade several years, 6th grade even more years. Now I'm stuck in 7th. But anyways, so what we're going to do then is make sure that they see division as the inverse of multiplication so that they can think through a long division problem. That's why I said up in the previous point that you must master those multiplication tables at the end of grade 3, or you're going to be stuck. Not only stuck with when you start taking off in 3rd grade and 4th grade with multiplication, 4th grade takes off in long division and fractions. And we don't want to be having to go back and pick up these basic skills as a 4th grader, or even some as a 3rd grader. Okay, so goals in primary math. First and foremost, we want to have a goal to lay a solid foundation by the time 3rd grade is over. And that is in number concepts. What's the most important number concept? Place value. Then in your basic arithmetic skills, both the procedure and their associated concept. What are the 4 basic operations of arithmetic? What are they? Yes, addition, subtraction, multiplication, and division. What's the most important addition procedure for primary? Carrying. Subtraction? Multiplication? Partial products. Division? What's that?
How to set up the problem.
How to set up the problem, exactly. So for addition, carrying. Got to hit that carrying, got to keep coming back to it, got to keep practicing it. Subtraction, we've got to borrowing. Multiplication. Yes, we have to start then learning to carry and use our partial products properly. Division, we just got to start setting it up, okay, and doing very simple division. All right, so overall, with, let's see, each one of those, what's the most important thing? For all 4, addition, subtraction, multiplication, and division, we went through 3 things, right? Procedures, concepts, facts. For addition, what is the most important thing to understand about addition? Out of all those 3 areas, which one do you think is the most important?
Procedure.
Nope.
Facts.
Nope.
Concept.
The law of addition is the most important thing for your primary students to carry away from. You say they don't need that till algebra when they learn to add like terms. No, they need it all the time. So from addition, yes, carrying is an important procedure, but the thing to bring away from the addition idea is the law. You can only add like quantities. And in primary, we will teach the law in the next section, the measurement section. Okay? All right. What's the most important thing for subtraction? It is the borrowing. What do you think is the most important out of the 3 areas for multiplication for 3rd graders?
Concept.
Nope. Times tables, times tables, times tables, times tables. Okay, I've dealt with a lot of 6th graders, 5th graders, and 7th graders who don't know their times tables. Okay, I have a 7th grader who's very, very weak on her times tables, and it's killing her. She can't keep up with us on our basic, when we're doing area, and she doesn't know times tables very well. So what happens? She understands area, she can use the formula, but her answer's wrong. It's just as wrong with her not knowing what 7 times 8 is, as it is if she doesn't know how to use the formula. You see what I'm saying? So, addition, what are you going to get down in your 3rd graders' heads, 2nd graders' heads, even 1st graders? You can only add likes. That's the law of addition. Subtraction, you got to borrow. Borrow. Multiplication, what is it?
Facts.
Times tables, facts. Division.
Procedure.
Yes, the procedure of just how to set the thing up. Make sense? So we're having a goal of providing a solid foundation. Okay, a couple of you don't have that foundation. what's it doing to you? It's following you throughout your life, right? So you want to give your students a solid foundation. It begins in primary. It begins in primary. And then if you have students that are missing pieces of their foundation, they're going to struggle. And they're not going to be able to concentrate on new procedures and expanding procedures when they have to keep catching up with their times tables. Okay, so solid foundation in number concepts, and then a solid foundation in your basic arithmetic skills with whole numbers. Okay, including concept and procedure, the procedure and the associated concept, and then with each of those 4 basic operations: addition, subtraction, multiplication, and division. A third area that we want to lay a solid foundation in is measurements. Measurements. With measurements, where are we going to begin? We're going to begin with learning basic U.S. customary units. Learning the basic U.S. customary units, starting with the familiar dozen and gallon and foot and inch, to the less familiar quarts and pints and cups, the less familiar yards and miles, the less familiar measurements. Second, we have to learn the basic measurement relationships, or the conversion factors between our U.S. customary units. So a lot of our measurement foundation in elementary and primary rather is going to be in measurement facts. First of all, we have to learn their names and what they are. That was number 1. And then number 2, we have to learn the relationships, the conversion factors. 1 foot equals 12 inches, right? 1 mile equals 5,280 feet, and everything that goes with it. Why did I call those conversion factors instead of facts? Because you always multiply or divide. And the older we get, the less we divide, and the more we just inverse our multiplication. All right? Then we also have to learn simple measurement conversion problems. And then simple measurement equations and simple measurement applications. So simple basic measurement conversions of U.S. customary units, feet to inches, miles to feet, gallons to quarts. We also have to do simple measurement equations where we're going to add 3 feet plus 40 inches equals how many inches? We have to convert, then add, and here's where the law of addition plays a role. We can only add like measurements. Okay, we can't add feet to inches. We have to convert, then add. Convert, then subtract. And then we also will do measurement applications. One of the best ways to start with story problems is using measurements. And often story problems have units. So we have to deal with measurement application.